What India has achieved with the Chandrayaan-3 mission to the moon was a scientific sensation. The two probes saw something that no one had ever suspected was on the moon. No other nation had dared to send probes to the rugged and extremely cold southern polar region of the moon before India. But then something went wrong, and since then, the global community has been wondering whether there will be any encouraging updates on Chandrayaan-3 or new images. For a long time, the current status of Chandrayaan-3 was unclear. The Indian Space Research Organization, ISRO, kept leaking news that raised hopes for new images and insights. On August 23, 2023, the Vikram lander and the Pragyan rover were deployed in a risky maneuver in a region near the South Pole. With the landing, India became the fourth nation to land on the moon. A few years earlier, the Chandrayaan-2 mission had failed miserably. When Chandrayaan-3 touched down on the moon's surface, there was great joy in India. The mission lasted 1 lunar day, which corresponds to 14 Earth days. Then both units were put into sleep mode. In India, researchers and engineers alike hoped to be able to reactivate the probes after the lunar night. However, the Indian Space Agency, ISRO, somehow forgot to install heating in the two units. Moon night means temperatures as low as -200 degrees Celsius in the polar regions. Attempts to reactivate them in September 2023 initially failed. In October, a message that was difficult to understand gave rise to speculation. Several attempts were made to receive a signal from the probes, but it was not clear whether they were successful. Vikram and Pragyan. Today, radio silence or new images for India. The mission of the two lunar probes was a complete success despite the failure to reactivate them after the lunar night. It sounds incredible, but ISRO had not expected to operate the probes beyond the lunar night from the outset, at least according to public statements. Millions of dollars were invested to keep a lander and a rover operational for 14 days and then shut them down. That sounds crazy, and it is, because the probes could have been operated much longer with the installation of a simple heating system. International experts criticize the moon mission as a waste, and doubts remain as to whether ISRO is simply trying to cover up the fact that it forgot to make the probes cold resistant, which would have involved only minimal additional costs. As a landing unit, Vikram was perfectly capable of transmitting data from the moon's surface for months or even years. The same applies to the small rover Pragyan, which did not even make it 100 meters onto the moon, swallowed up immense costs, and after the first few days, was only able to deliver a small sample of its capabilities. For a long time, the international community of scientists and technology enthusiasts hoped for further updates on the mission and a detailed report on the real status of Vikram and Pragyan, and of course, new images. Reports circulated online that ISRO had managed to revive the two after all. However, the news and allegedly published new images turned out to be fake. ISRO finally admitted once again, officially and unequivocally, that the systems are irreversibly frozen or damaged, and that no new data has been available since fall 2023. Despite its short active phase, Chandrayaan-3 is officially considered scientifically complete. Chandrayaan-3 in facts and pictures. Before this mission, no other nation had achieved what India did. The target region at the south pole of the moon was an absolute first, and the two probes landed using a new, fully automatic control system. Both achievements earned India respect in space circles. On August 23, 2023, Indians celebrated the success of the unique landing maneuver. Due to the location of the South Pole as seen from Earth, direct radio communication with the probes was not possible. The delay of 1.5 seconds is sufficient to guide probes that are already on the moon's surface, but the time difference is disruptive when it comes to landing probes in real time. Minimal deviations can lead to serious accidents. With Chandrayaan-3, ISRO presented a highly innovative automatic landing system that allowed the probes to steer and land autonomously with the aid of cameras and built-in intelligent navigation. The carrier probe scanned the environment in real time during the landing approach and corrected the flight path independently. A few days after landing, ISRO presented the first photos of Vikram and some of Pragyan, the rover, rolling out of the belly of the landing unit and successfully navigating the lunar surface. The Vikram lander took its first measurements and delivered solid data. Vikram and Pragyan transmitted the data to a third probe positioned in lunar orbit, from where it began its journey back to Earth. The mission objectives of the two probes were to take temperature and climate measurements and gather initial findings about the actual conditions at the Moon's South Pole. Future Moon missions will include South Pole exploration tours to determine whether and how much water is actually present there. Vikram and Pragyan were equipped with over a dozen scientific instruments for their maiden mission. Vikram used a laser to examine moon rocks and discovered that the water deposits in the soil are probably deeper than previously assumed. The two probes used a seismometer to measure several moonquakes and scan the meteorological conditions. They had 10 days to complete their measurements and explorations. Then lunar night fell, and the rest is now part of space history. Chandrayaan-3 and the discovery of sulfur at the lunar South Pole. One of the most significant scientific breakthroughs of the Chandrayaan-3 mission was the discovery of sulfur. During its short mission, the Pragyan rover performed laser-induced spectroscopy and found the coveted raw material. In this process, material is vaporized with a laser, and the resulting light spectrum enables perfect elemental analysis. This was the first direct in situ measurement of its kind on the Moon and confirmed not only the presence of sulfur, but also aluminum, iron, calcium, titanium, manganese, silicon, and oxygen. Sulfur deposits had previously only been suspected based on data from lunar orbiters, such as the Lunar Reconnaissance Mission, but had never been detected on the Moon's surface itself. The Indian Lib sensor was able to analyze highly precise element concentrations in tiny dust and rock samples within a few seconds. This achievement alone makes the Chandrayaan-3 mission an overwhelming success in expert circles. The high sensitivity even allowed for a precise distinction between surface and subsurface samples, as the rover's 6 wheels enabled it to easily examine slightly raised crater rims. Sulfur could be just as interesting for future colonization of the Moon as it is for industrial use. For scientists, the discovery provides evidence of volcanic activity in the Moon's past. The sulfur was linked to other minerals that are typical of hydrothermal processes. The Moon as a source of raw materials for the future. The discovery of sulfur could mark the beginning of a whole new era of lunar exploration. Earth's satellite could be an interesting source of raw materials in the future. In the 1990s, Mars appeared in the Hollywood blockbuster Total Recall as a planet colonized by humans with mining activity. While that still sounded like pure utopia, it may not be so far off before the Moon is colonized and serves as a source of raw materials for us. Recent discoveries of highly interesting rare materials are casting the Moon in a completely new light. If the Moon is a potentially rich source of rare and industrially valuable elements and can also be reached within a realistic time frame, this could give space technology an enormous boost. Research is currently focusing on 3 areas in particular: helium-3, metals, and geochemical elements such as sulfur, oxygen, and hydrogen. Helium-3, the energy source of tomorrow. The helium-3 isotope found on the Moon is suitable for clean nuclear fusion processes. Some people still believe that our scientists are not capable of nuclear fusion, but that is not true. Nuclear fusion is possible, but currently only with isotopes whose calorific value does not compensate for the energy required for fusion. In plain language, this means that we need more energy to fuse the nuclei than is subsequently generated. There are a few elements that are very easy to fuse, but they are so rare on Earth that mining them and switching to this technology would not be economically viable. Even if we consider that nuclear fusion leaves no dangerous residues and could solve our energy problem, helium-3 from the Moon could change that. The isotope is considered a potential fuel, and 1 kilogram of helium-3 could release about 10,000 times more energy than fossil fuels of the same mass. Mining it on the Moon would be costly but technically feasible. It will only become economically viable when the amount of energy produced exceeds the cost of extraction and transport. If we have to put more energy into launching rockets and fueling space freighters, the energy balance will not add up. However, it's probably only a matter of time before rockets and space freighters are so effective that transport will be worthwhile. Elon Musk has already revolutionized space travel with his rockets and spaceships. Thanks to his commitment, rocket launches are now possible at almost half the price they were 20 years ago, and space travel could soon become affordable. Once we have the infrastructure and spaceports on the moon, as well as the necessary resources for life, the moon would be a completely realistic source of raw materials. At the moment, the moral debate is still raging as to whether we should be allowed to exploit another celestial body for industrial purposes. However, if there is no other solution to our energy problem, even the most ardent environmentalists, or rather, space conservationists, will have to compromise. Further questions arise as to who actually owns the moon and how the global community could share ownership and usage rights without falling into conflict. The polar regions of the moon are particularly interesting in this context, and India has proven with its Chandrayaan-3 mission that it's already possible to explore these areas with probes. The moon's crust has been proven to contain traces of rare metals such as titanium, aluminum, iron, silicon, and magnesium. These minerals are essential in space technology, microelectronics, and the energy industry, and mining them on Earth has become difficult in some cases. Some rare earths are already so scarce that companies are systematically recycling electrical appliances to extract the raw materials and reuse them. Chandrayaan-3 has detected sulfur directly on the moon's surface for the first time. In combination with other elements, sulfur can be useful for building materials or energy production in lunar colonization. The raw material provides moon concrete and sulfur batteries. The existence of bound water and oxygen in lunar minerals is important for long-term missions to the moon and eventually for the habitats of humans who will live on the moon permanently or for extended periods of time. Water can not only be drunk, but also split into oxygen and hydrogen. The latter can be used as the perfect fuel for lunar vehicles and even rockets. Several spacefaring nations and private companies, such as SpaceX, Blue Origin, and Astrobotic, are already developing technologies for the further automated exploration of industrially interesting regions of the moon.